In chapter 6, we're going to take a look at polygons and quadrilaterals. The first thing that we're going to check out in chapter 6 is the polygon angle sum theorem. And what this is going to tell us is how many degrees are there for the interior angles of any polygon based on the number of sides. So the n in this formula is going to represent the number of sides. So we're going to subtract 2 from the number of sides and then multiply that times 180. So how exactly will this work? Well, let's check out. If we have a triangle, we know that we have 180 degrees. If we have a square or a rectangle or any sort of quadrilateral, we know that we have 360 degrees. So then how many degrees will we have for the pentagon? Well, what you see is that going from the triangle to the square, we've added 180 degrees. That's going to be true anytime that we add a side to a polygon. So if we go from 360 or from a square to a pentagon, we should add 180, which will give us 540. Let's try it out with the formula and see if the formula works. So we know that we've got 5 sides minus 2 times 180. So that's going to give us 3 times 180, which is 540. So it checks out for the polygon. This is going to work for any sort of polygon that you've got, whether it be a triangle or all the way up to a 15-gon, 100-gon, whatever. Whatever size polygon you want to use, it's always going to work for that. Let's move on over to problem number 1. And in problem number 1, it asks us, what is the interior measure of the angles for a heptagon? So hepta means 7, so we've got a 7-sided polygon. So we're going to go 7 minus 2 times 180. So 7 minus 2 is 5 times 180. 5 times 100 is 500. 5 times 80 is 400. So put those together and you get 900 degrees. So in this heptagon, the interior angles add up to 900 degrees. Before we move on to problem number 2, we need to define some terms first. In this drawing here, you have a hexagon that has been smushed down, but all of the sides remain the same length. So what we have is an equilateral polygon or an equilateral hexagon. Now remember that the prefix EQUI or the root EQUI means equal and lateral means side. So anytime that you see equilateral, it's always talking about equal sides. In our next polygon, what we see has happened here is that this has been stretched this direction. Now, all of the angles remain the same degree measure, but the sides are different different side lengths. So what we have now is an equiangular hexagon. Then, if we take these two and put them together so that all of the sides and all of the angles are the same, then you get what is called a regular polygon, or in this case, a regular hexagon. That brings us to the corollary to the polygon angle sum theorem, which states that for one interior measure, to find a single interior angle, so we might be talking about that one, on a regular polygon, okay, then what you're going to do is you're going to do n minus 2 times 180, which is our polygon angle sum theorem, but then you're going to divide that by the number of sides. So we have n minus 2 times 180 over n. In problem number 2, we're given a word problem about an insect's eyes and the eyes being made up of a bunch of hexagons. We're not going to worry about working out the word problem. We just want to look at how do we find out the hexagon. So what we're being asked is, what is the angle measure of just one of those angles? So what we're going to do is take this formula, n minus 2 times 180, but we're going to replace the n with 6. So we're going to go 6 minus 2 times 180 divided by 6. So we get 4 times 180 divided by 6. Now at this point, what I could do is, to make the math a little bit easier on this, I'm going to reduce the 4 and the 6 down to a 2 and a 3. And again, that's just going to make the math a little bit easier. 2 times 180 is 360 divided by 3. And then so 360 divided by 3 is 120. So one interior measure of a regular polygon is 120 degrees. In problem number 3, we're being asked, what is the degree measure of angle y? Before we can figure out what the measure of angle y is, we need to determine how many degrees are there in this polygon. So we have a 1, 2, 3, 4, 5-sided polygon. So let's go ahead and plug that in to the angle sum theorem. So 5 minus 2 times 180, and that's going to give us 3 times 180, which is equal to 540. Again, one of the things you may want to do as we move along is go ahead and start memorizing some of these measures. So a triangle is 180, quadrilateral is 360, a polygon is going to be, a pentagon is going to be 540, and then a hexagon is going to be 720, and then we'll move on beyond that. So we've got 540 degrees total in this pentagon. So now what we've got to do is figure out what is the measure of y. So if we do y plus 110 plus this 90 plus the 120 plus the 150, that's going to be equal to 540 degrees. So now it's just a matter of combining like terms and then isolating the variable. So 110 plus 90 is 200. 120 plus 150 is 270. So 200 plus 270 is going to be 470. So we get y plus 470 is equal to 540. Subtract the 470, and we're going to get y is equal to 70 degrees. So we know that this angle measure right there is going to be 70 degrees. Before we move on to problem number 4, we're going to take a look at the the polygon exterior angle sum theorem. So what this states is that for the exterior angles, if you add up all of the exterior angles of any polygon, the measure is always going to be 360 degrees. It doesn't matter if you've got a triangle or if you've got a 100-gon. Whenever you add up those exterior angles, the exterior angles will always add up to 360. Let's take a look at how this works. If we have a regular triangle or an equilateral triangle, then you can see that we've got 60-degree angles for each of the interior angles. So if we draw a spoke off of each angle, what we get is one exterior angle. So you can see that because they form a linear pair, if this one's 60, this one's going to be 120. This one's 60, this is 120, this one's 60, this is 120. So if you add up all of those 120s, you get 360 degrees. Same thing happens down here with a square. We know that a square has 90-degree interior angles. If you draw a spoke coming off of each interior angle, then you can see that by forming a linear pair, all of those exterior angles have to be 90 degrees. Since there's 4 exterior angles and 90 degrees, then we get 360. This is going to work for any polygon that you've got. So let's take this idea over to problem number 4 now. In problem number 4, we're given an octagon which has exterior angles that have been drawn off of it. And we're asked, what is the measure of a single exterior angle? So not the sum of them, but one exterior angle. So what we're going to do is we're going to use the polygon exterior angle sum theorem to tell us, hey, there's 360 degrees for these exterior angles. And since there are 8 angles, then if this is a regular octagon, all of those exterior angles are going to be equivalent or equal to each other. So all we're going to do is go 360 divided by the number of angles, or the number of sides. So 360 divided by 8. 360 divided by 8 is going to give us 45 degrees. So every single one of these exterior angles in that regular polygon is going to be 45 degrees, including angle 1.